All right, this question says an empty trailer, it's 1,000 kilograms, travels at 10 meters per second down the road. As it rains, 100 kilograms of water fills the trailer. The trailer maintains the same momentum. What is its new velocity? So you basically have an empty cart that's moving, has a mass of 1,000 kilograms, and is moving down the road at 10 meters per second. Then this cart fills with water such that the new mass includes 100 kilograms of water. So we want to know how fast the object is moving if it maintains its same momentum. So we're looking for, I'm going to call it final velocity just so we can keep it straight. But this final velocity term, we're going to use the principle P equals mv. So we have, basically we have to do this calculation twice. We have situation number one, which is when it's empty. When it's empty, I know that I have a mass of 1,000, and I know that I have a velocity of 10. When in the second situation, I know that I have a mass of 1,000 plus the other is the mass of the water. So the total mass would be 1,100 kilograms. And I know I'm trying to solve for the final velocity. So you can use P equals mv, right? So I have the momentum of the object when it's empty, and I have the momentum of the object when it's full. So instead of solving for the momentum of the empty and then plugging it in, what I'm going to do is I'm just going to say, okay, well, the mass times the velocity equals the mass times the velocity. And this is just an example. We'll learn a little bit more about this later. This is just showing you conservation of momentum. It turns out that a lot of times momentum is conserved just like it is in this particular example. So you have the mass of the empty cart, the velocity of the empty cart. So 1,000 times 10. On the other side, you have the mass, which includes the water, and then you have the new velocity. So, as you would expect, if you start to fill a trailer with water, you would expect the cart to slow down, and that's exactly what happens here. We say 1,000 times 10 divided by 1,100, because we divide both sides by 1,100, and you get the new velocity is 9.1 meters per second.